Okay, now that you've tried them, let's go over these problems. So the first one, ask yourself, what's the first thing we're going to ask ourselves? Yes, is it in standard form? Oh, what do we need to do to put it in standard form? Subtract 3 from both sides. So we get 6x squared minus 7x minus 3 equals 0. Now, of course, you could try to factor it, but this would require the AC method. We're not going to factor it. We're going to use the quadratic formula because that's what it says to do in the directions, right? We read the directions. So now we have to identify A, B, and C. So I need a lot of space, as you can see. So I'm going to write them up over here. A equals what? B equals -7, and C equals -3. Now, do you think that makes a difference if the 3, see, a lot of people will forget to put it in standard form and they'll use a +3. Would that give me the same answer as if I used a -3? Absolutely not. Okay, now let's use the formula. X equals -b. Okay, -b is what? 7, because it's the opposite of -7. Plus or minus square root b squared. What's b squared going to be? It's 49. That b squared, you guys, doesn't matter, will always be positive, because if you square -7, you get a positive 49, okay? Minus 4 times a, which is 6, and times c, which is -3. Good. All over 2a. What's a? 6. Okay, great. 7 plus or minus the square root. Now I'm going to simplify inside the radical. 49. What's this last part? And this is important. You want to show all work, because when you make a mistake, we want to be able to find out where it is if you make one. So we have negative times a negative. Anytime you have two negatives here, you'll have a positive, because you always have that in the formula. So then 24 times 3, isn't that, what is that, 72? What's 24 times 3? 72. Okay. 72 all over 12. 7 plus or minus the square root. 72 plus 49. I don't know. I'm going to get my calculator out for this one. What is it? 121? Oh, how convenient. Over 12. Now you see what happened here. 121 is what kind of number? Perfect square. So we have 7 plus 11 over 12, or 7 minus 11 over 12. We have both answers. Okay, could be solutions here. So 7 plus 11, that's 18 over 12, which reduces down to 9 over 6, which reduces down to, am I doing this right? You guys have to tell me. What is that? 3 over 2? Yeah, because 6 goes in here 3 times, 6 goes in here 2 times. So 3 halves. And then here we have 7 minus 11 is -4 over 12. What does that reduce down to? -1/3, right? Because we have the 4 in the numerator and the 12 in the denominator. So our solutions here are 3 halves and -1/3. By the way, you guys, that means this could have been factorable. Okay, your factors would have been, if I added 3, that was a -3. If I divided by 2, I had 2x. This factor, if I subtracted 1, that meant it was a +1. If I divided by 3, I had a 3x. So this actually would have been the factors if we had factored it. Anytime you have a perfect square inside the radical, it actually means that you have something that was factorable. Okay? Let's do the next one. So, is this one in standard form? No. So what do we need to do? 3x squared, you're going to subtract 6x, and you're going to add 2, right? Now is it in standard form? Any questions about how we got that? So what's my A? What's my B? And what's my C? Very good. Okay, now we plug it in. X equals negative B. Who can tell me what negative B is going to be? 6 plus or minus the square root of B squared. What's B squared? Negative 6 squared is 36 minus 4 times A. What's A? And C? 2. All over 2 times 3. Oops, 2 times 3. I don't know. I was already jumping to 6. Okay, any questions about that setup so far? Let's keep going. We're simplifying. 6 plus or minus the square root of 36 minus what? Minus 24? You see where I'm getting 24 instead of 12? 4 times 3 is 12 times 2. Okay, all over 6. 6 plus or minus the square root of 12 over 6. Okay, now this one did not have, 12 is not a perfect square. But remember, we want to simplify. That's what we learned in chapter 7. So how could we simplify the square root of 12? Hopefully by now you almost have it memorized. What number, what's the perfect square in 12? 4. What's the square root of 4? 2. What's left? 6 plus or minus 2 radical 3. Does everybody know how we got that? Over 6. Now, one thing I want you to realize is this is not fully simplified yet. You could look and see all of these whole numbers right here, these integers, right? They can all be reduced. This is the same thing as 6 over 6 plus or minus 2 radical 3 over 6. So we want to think about what's a number that goes into 2 and 6 evenly. It'd be 2. So this is the same thing as this goes into 2, or 2 goes in here 3 times, 3 plus or minus. 2 goes into 2 how many times? Yep, so leaving radical 3 over 3. This is the simplified answer. It could also be simplified as 1 plus or minus radical 3 over 3. But you see, if I wanted to add these back, I would need a common denominator, hence the 3 over 3. Okay, so this is how we would simplify. We want to simplify the radical and then look and see your 3 numbers. Do you have one that divides in? This is probably more customary right here, and we can talk about how to check this too. To check this, you would really want a decimal. In fact, why don't I, while I'm on the subject of checking, why don't I just show you how you would check it, okay? Realize that this is 2 different answers. What do I mean by that? Well, the plus or minus would split it into 2 different answers. So if I wanted this as a decimal, I could go, I'm going to do it in a different color, okay? 3 plus radical 3 divided by 3, or 3 minus radical 3 divided by 3. Does everybody see why I would separate those 2? Okay, if I wanted to find the decimal approximation, I would go 3 plus the square root of 3, enter, divide by 3, just because I didn't want to do parentheses. Okay, so this first one is approximately 1.58 if I rounded it, okay? If I wanted to plug that number in to my equation, which is here, I can do this. 3 times A and S. Do you see this button right above the 0? If I use second A and S and I square that, that should be, that number, whatever that is, should be equal to the other side. 6 times, I'll go grab this A and S up here, 6 times that number minus 2. You see how they're the same? Basically, when I check, I take a solution, I plug it into both sides. If it works, then it's the solution. Okay, let's try to check the other one. 3 minus the square root of 3. I'm going to divide that number by 3. Okay, this one is approximately 0.42. Okay, now if I check 0.42, it's not going to come out exactly. But if I go 3 times that answer squared, okay, that should be the same thing as 6 times that answer minus 2. Is it the same? And it's a decimally number. That's fine. We just care that they're equal, that both sides are equal. That's the idea of checking, okay? So you can always, anytime you get a solution, whenever you solve, you can always plug that number in and